Okay, so if we remember yesterday, in yesterday's lesson, just to recap, if we go way back to the beginning, we started with relations and functions. Every single thing that we can graph, every single thing that's set up in a table, every single thing that is set up as a set of ordered pairs, those are all considered relations. But not every relation is a function. A function only occurs if two numbers never repeat, or more numbers never repeat in the x spot, the x coordinate of points. That is also called the domain. The domain cannot repeat. If the domain ever repeats the same number for two different y numbers or two different range numbers, that will create a vertical line, and vertical lines are considered not functions because they have undefined slopes. Then we looked at different examples to determine which ones were and were not functions. All of these things are relations, but only some of them were functions. The ones that don't repeat the same x numbers, like letter B, 1, 2, 3, 4, 5, 6, they never repeat, so that is a function. Only those situations will be functions. Then we looked at equations that were representing y as a function of x. That means that it can easily be solved for y equals. We skipped these. We looked at function notation, which is a fancy way for saying y equals. This whole end of the chapter uses function notation, so it's important for you to understand that the letter in front is just naming the function. So this is like the function g of the function x. G of x is how you would say this. The x is the domain, and then the answer is the range. The last thing we're going to do is find domains and ranges of functions. So these functions that they're giving all have specific domains and ranges. So the first thing that I'm going to do is insert this function into my graphing calculator so that we can see what this looks like. If you have a graphing calculator, it will be helpful for you to follow along with it. If you don't, you can follow along with mine up here at the front. To insert a function into your calculator, you should be hitting y equals, and when you hit y equals, you can put in as many different functions as you need. Right now we're just going to put one in at a time. The first function they give us is f of x equals 1 divided by x minus 3. F of x or g of x or h of x, all of those things really represent y equals, so don't get confused with that. This is going to be y equals, you would hit 1 divided by, and you're going to need parentheses here, 1 divided by parenthesis x minus 3, close the parenthesis. Now what we're going to do is hit graph to see what this looks like. So this is a very weird looking graph. So I see that it like starts over here and then goes down this way, starts over here, goes this way. It's not like a nice easy line that we're used to seeing. It's not a nice easy, maybe like U-shaped graph or anything like that. This is definitely a weird graph. If I look to see what the domain is, the domain means what x numbers will work for this graph. So looking at all of the x numbers, that means that you're looking at the x-axis and seeing what x numbers will work. And sometimes your domain will just be a list of x numbers. Like if I said, what's the domain for these three ordered pairs? The domain would be just listing the three x numbers in those ordered pairs. But the domain and range for graphs like this usually go on forever and ever and ever, because graphs do go on forever. Functions that just never stop, the domain sometimes will be negative infinity to positive infinity. But this one's a little bit interesting. If I hit second graph, it's going to open up to a table of values. And I can scroll up to see more negative numbers. I can scroll down to see positive numbers. But then I see right here at the center that there's something strange that happens when x is equal to 3. When x is equal to 3, it says that there is an error right here. It says that it can't calculate a number when x is equal to 3. And if I go back to the original function right here, f of x equals 1 over x minus 3, I can see here it does tell us that the domain will be all of the numbers except for when x equals 3. Why does 3 not work for this? Devin?
The original problem says x minus 3, so if you do 3 minus 3 equals 0.
Exactly. So in the equation, if we have 3 in here, 3 minus 3 is 0, and we can't divide by 0. So the domain is any number for x except for when x is equal to 3. So the domain for this function is any number except for when x equals 3. And I can see that in the graph as well. If I look on x, 1, 2, 3 right here, that's when these vertical lines start happening. If you look here, it's like a curved line, and all of a sudden it goes completely vertical at 3. And that is because 3 does not exist in the domain. Now, there's different ways to show domains. Domains can be listed as with like the same type of notation we use in the inequality section, or it can be used with the same type of fancy notation that we used prior to that. But I think the easiest thing to do to list the domain would be using inequalities. So looking at this graph, I'll go back to the graphing calculator again. To list the domain, but I do want you to write this in right here, but I'm going to write it on my calculator. To list the domain, that means to list all of the x numbers that will work for this graph. Any number over here will work for this graph. Any number over here will work for this graph for x. Any number over here for x will work. The only number that does not work is when x is equal to 3. So to use inequalities to show that, I know that this graph goes on forever and ever and ever in this direction. That means that the smallest number that can be used for the domain is negative infinity. Negative infinity is not a number, it is a concept, but that is the smallest number that we would use. That would be the smallest number in our inequality. And then this inequality will then, for the domain, which is x, it will stop at 3. So it goes from negative infinity to 3 and then stops. And then it starts again at 3 over here and goes to positive infinity over this side. Now 3 is not included, which is why I don't have a less than or equal to symbol. So the inequality for the domain would be negative infinity is less than x is less than 3, and 3 is less than x is less than infinity. And that's where I would want you to write it right here. It's easier to say all numbers except for when x is equal to 3. That's easier to write. And the inequality would be negative infinity is less than x is less than 3, and 3 is less than x is less than positive infinity. All right, looking at the domain of the next function. To do this, the easiest thing would be to use your graphing calculator. If you don't have a graphing calculator, I highly suggest going to TI-84, Googling that, and then downloading a free trial. It'll give you 90 days if you don't have one. And then once those 90 days are up, I would Google Desmos, D-E-S-M-O-S, and that has a free calculator. It's just not as user-friendly as this one. And when you go in here, to do the next one, to see the domain, there's really no other way to do it unless you know what these graphs look like. So graphing calculators are everything right now. To find the domain of this, we would hit second and x squared, and then we'll open up the square root button, and you're going to insert an x here. So second x squared, and then insert the x, and it's going to look like this. When you hit graph, you're going to see what the graph of the square root of x looks like. So we want to list what the domain is. That means what number x can be for this graph. Looking at this graph, I can see that there are no values over here in the negatives. So looking at negative x over here, there are no numbers. This graph starts right here at 0 on the x-axis, and the domain is just the x values. The range we haven't really even looked at yet. That's the y values. So for the domain, the smallest number is x, which is why they already have listed here the domain are all numbers that are greater than or equal to 0. 0 is a part of this. If I look at the table, second graph, I can see that 0 is a solution. So if I look at 0, it's 0, 0. But anything less than 0 doesn't work. It's not there. It doesn't exist. So 0 is the smallest number for x. And then it continues on forever. Anything greater than or equal to it will work as well, which is why the domain is anything greater than or equal to 0. So to find the domain, You would put it in your calculator, see what the graph looks like, and then determine, okay, what values of x will work for this graph. These have not asked us to find the range just yet. I'm not sure why they're not asking us for the range, but the range is the same thing as just looking at what the y values will be. So letter A and B over here are asking us to find the domain of each function. The easiest way to do this is to go into your calculator and go to y equals and type in these functions. So for for f of x equals the square root of 2x minus 6, to do this, we would go to second, x squared, 2x minus 6, and I'm going to do these problems with you. Normally I would have you try these, but not everyone has a calculator, so I'm just going to show you what to do. And when I go to hit graph to see what it looks like, here's what this graph looks like. So it looks similar to the f of x equals the square root of x1. It's just moved over a little bit. And it's asking us to determine what the domain is. That means what x values work. Looking at this picture, where do you think the smallest x number is? What's the smallest domain number? I know it's kind of hard for you to see maybe if you're here. But looking at this graph, or if you have your own graphing calculator, what's the smallest number for x?
3.
Yes, thank you, 3. So looking at this, I can see here the x numbers start here at 3. If I look at the table as well, I can see if I scroll back down that anything that's less than 3, it's going to say error. That means the smallest number for x is 3. That means the domain is anything for x greater than or equal to 3. The next one is very tricky. We have to be careful with this. When we go into y equals and put this next one in, we're going to need a ton of parentheses to show what's going on here. Because we have a lot of different terms in parentheses already, and this is division, we're going to need parentheses 4x, parentheses, divided by, and then we're going to need 2 sets of parentheses down here. Where is this? It's going to be x minus 1, parentheses, x plus 5. Oops. And once I put this into my graphing calculator and I hit graph, I see this crazy looking thing. And I'm trying to figure out what the domain and range will be. So looking at this graph just seems like it's just like a U-shaped graph. It looks like it's kind of slanted. But if I go to the table, second graph, I'm looking for situations that I have an issue here. What's going on here? Did I put this in right? Hold on. All right, sorry. I needed another set of parentheses here. So for those of you who put this in your calculator and followed me, we needed another set of parentheses to show this whole thing is being divided by. So you need an extra set here and here, so an extra beginning and end one. But no stress. I would help you put that in on a test. So looking at this one, here's what this graph should look like. This is even crazier. So we have 3 different lines here. We have 3 lines that are going vertically. These are called asymptotes. If I look at my table, I'm going to see errors at 2 spots. I see an error at -5 and I see an error at 1. And if I look at the function again, it makes sense just like that original one. The original one, x could not equal 3 because when you put 3 in for x, 3 minus 3 is 0 and you can never divide by 0. The same thing happens here. Look for the errors. The error is at -5. And the error is also at 1. And that's because if you put a 1 in for x, that entire denominator will turn into 0, and that can't happen. If you put in a -5 in for x, that entire denominator will be 0, and that can't happen either. So this domain, the easiest way to just write it, I'm just going to write it like they did the first one here. The domain is any number for x is all x's except for what two numbers? Yep. 1 and -5. So the easiest way to write that is just that. All numbers except for 1 and -5. Now we actually could tell that from the equation for B here in the first example here. But the best way to do this is to use your calculator to just see what's going on and see what the table of values tell you. Yes?
How would you find the range then?
So the range, if you're looking at the graph, this range is kind of crazy because the range for this will be literally any number. The range, instead of looking at x, you're looking at x and then you're looking at y. So looking at the y numbers here, these are all going to be going on forever and ever in all of these directions. And because, just looking at this line in the center, because this arrow is always going up and this arrow is always going down, there's always going to be a number that y goes with. So the range for this one will be all numbers. There are going to be no numbers for y, if we look at the table too, that have that aren't going to be able to exist. I know that 1 doesn't exist for x, but if we're looking for what y is, like y can be any number from positive infinity to negative infinity. And this is kind of a harder example to see. If I'm looking at an easier example, like let's do the square root of x for that example up there. The question was, how do we find range? So if I look at an easier example like this other one we did, the square root of x, the domain is looking at your x values, and the x values are anything that's going to be greater than or equal to 0. Y values is when you're looking opposite. So you're looking at the y values and thinking to yourself, okay, where are these numbers going? Well, this line is going forever and ever and ever up to positive infinity. And looking at y, the smallest number we have, smallest number we have for y is 0. And then it's going to keep going up and up and up and up and up forever. So the range for this is going to be actually the same as the domain. It's going to be anything bigger than or equal to 0. If we're looking at another equation, let's just do another example just so we are sure we understand. Like y equals x squared. So I'm going to put x squared. The range is going to be anything x can be. And x can be any single number here. There's never going to be a time where an x number can't be put into this equation. You can put in any number into the equation and then square it and get a y number. However, the range is the numbers that are going to be, like looking here at the vertical line. Looking here at the vertical line, what's the smallest number on the y-axis that this can be? 0. So the range starts at 0 and then goes on to positive infinity. So I don't know why these examples don't say domain and range, and then these two do. So we'll talk about domain and range in these two. So finding the domain and range of these two functions. So letter A is the easiest type of example because letter A only lists ordered pairs. If you have a list of ordered pairs, this is the easiest thing to do. The domain, you just list the numbers in the X. And you're supposed to list them from least to greatest, but honestly, I'm not going to be picky. The domain for ordered pairs, you just list all of the X numbers like so. The domain would be -3, -1, 0, 2, and 4. This only works for when you have ordered pairs that are just lists of numbers. As soon as you have a function, you have to give me like an inequality to show me the smallest number and the biggest number it can possibly be. The range then are all of the lists of the numbers in the y coordinate spot. So that would be 0, 2, 4, 4 again, we don't have to write that, and -1. Now, technically, like as soon as you get to higher level math courses, Mr. Eichler, Mrs. Lambert, anyone who teaches those higher level courses, they're going to get mad if you don't put them in order from least to greatest. So I want you to try to. The smallest number in the range is -1, and then 0, 2, 4. So the domain are your x values, the range is the y values. They want us to find the domain and range of this equation here, that the area of a circle is equal to pi times radius squared. Now we're used to using x and y. In this case, A, the area is really like y, that's your dependent variable, And it depends on what the radius is, which is really like x. So I could actually put this in my calculator now that I changed the variables to be x and y. So if I wanted to, I could go back to my calculator and put this in y equals. So y equals pi. It's pi in a while. Where is it? Second. And then x squared. And I can go to my graph, and I can see what it looks like here. It's another parabola. And it will help me determine what the domain and what the range are. So if I look at my table, I can verify just from the graph, but there's going to be no times where we're going to get an error as our answer because literally any number can be put into this equation. You can put any number in for x, a positive, a negative, a fraction, anything, and square it. That's just multiplying it by itself and multiply it by pi. So any single number for x will work. So the domain is really any number. Whenever something's asking you to write the domain, sometimes it's going to be tricky in its notation. You're going to be seeing it written a ton of different ways, and you have to understand it's all saying the same thing. The domain can really be written down as like everything. Like the domain for this one is all real numbers, anything. So it can be any numbers. That's one way to write it. You can also write it in inequality form. The smallest number that's a real number is negative infinity. And the biggest number is positive infinity. So another way to write the domain is negative infinity is less than x, which is less than positive infinity. And then another way to write it is just showing it like starting at negative infinity to positive infinity like that. So there's many different ways to write it. I don't care which way you write it. You have to honestly understand what they all mean. As long as you write it one way and what you're saying is correct, it's cool with me. The domain is not all real numbers in this case. I meant to say, did I say domain? I meant to say range if I didn't. The range is not every single number. The range is the y values. The y values has a minimum here in this case. What's the smallest number that will be seen in this equation? What's the smallest number that we will see for y in this equation? 0. And I can see it from the graph. Looking at the graph, the smallest y number is going to be 0. So the range is going to be anything bigger than or equal to 0. So anything, I don't feel like writing that, but I could write it out in words, anything bigger than or equal to 0. I prefer to just write it as an inequality. Range represents y, so I'm going to write y is greater than or equal to 0. That's one way to write it. What am I doing? I don't know why I wrote 1. I meant to write 0. Or you could write it like this format. You could write from 0 to positive infinity like this. But if you do it this way, it will have to be a square bracket because 0 is included. And you might be confused with these notations. We did this in section 2.7, I think. Okay. So because of time, I want to skip that word problem, and I want to move over to the next page. And I just want to quickly talk about the basic graphs of functions and whether or not graphs can be functions or not. So these are the 6 basic functions that I will want you to kind of know what they look like. If you are ever not sure and you forget, you can easily put them in your graphic calculator. But here they are. These are all using function notation. So instead of using y equals, I'm going to be using function notation as well. But then when you use your calculator, you have to use y equals because it doesn't understand function notation. This is a horizontal line. This notation is f of x equals c. This is the same thing as like having just an equation like, for example, y equals, this looks like it's like at 1.5. So this is the equation y equals 1.5. But the notation, the basic graph of this, the parent function we like to call it, is f of x equals c. These are all parent functions I should also write here. So these basic functions are also known as parent functions. So these are like the original function for each type of graph. This next parent function is f of x equals x, which is also known as like y equals x. This is the parent function of linear equations. So a linear equation that has a slope of 1 and passes through the origin would be the equation y equals x, or f of x equals x. This next one, f of x equals the absolute value of x. This is an absolute value graph, also known as y equals absolute value of x, like this. This one we saw in a couple examples. This is y equals the square root of x. We saw this, I feel like, already today. This is y equals x squared, and this is y equals x cubed. So we have a constant equation, we have a linear function, we have an absolute value function, we have a square root function, we have a quadratic function, and a cubic function. All of these 6 are actually functions. And they are all functions because they all pass something that is called the vertical line test. So if I scroll down here, there are some times that graphs are not functions, and that is when a picture of a graph crosses 2 points or more on the same vertical axis. Like if I take y equals x squared, which usually looks like this, and I rotate it this way to look like this sideways, it's not a function anymore. Because you could make a vertical line anywhere, and anywhere you would make a vertical line, it's going to cross through more than 1 point. And we already know that when lines pass through more than 1 point on the same vertical line, it's not a function anymore, and that's called the vertical line test. So whenever you look at a vertical line, you can take your pencil and you just go like this, and you just go through the graph. If you will ever cross more than 1 point on the same vertical line, it fails the vertical line test, which makes it not a function. So the last thing we're going to do today is just quickly go through these 4 and determine which one are functions and which ones are not. Looking at the equation, I can already tell from the equation that it would be very hard for me to solve this thing for y. It doesn't say y equals, and I see that it says y squared, and I know that when I do that, I'm not going to be able to solve for y. That's one way to show it's not a function. Another way is to look at the vertical line test. I could draw a vertical line literally anywhere on the circle and pass through 2 points. As soon as you pass through more than 1 point, that's not a function. So this is not a function. How about the second one? Is this a function? Yes, I can tell 2 ways. First, it's solved for y. Equations that can be solved for y are functions. And also, if I drew a vertical line anywhere on these graphs, I will only cross through 1 point. So yes, this is a function. This third one, is this a function? No. And what about the last one?
Yes.
Yes.